Hello everyone. Am I audible?
Yes.
Fantastic. Well, welcome to this session. And then we'll wait 2 more minutes, like 3 more minutes, and then we'll be starting the session.
Yes.
Well, welcome to this session. And we'll wait 2 minutes. This session will be chaired by Professor Shamim Kassar, and we have 5 papers in this session. So paper number 35, 79, 96, 115, 89, and 90. This session So may I request the attendees of the papers, with our presenters of the papers, just to write in the chat their paper number so that we can know that we have all the presenters available here and they can be given the necessary privileges to share their screens. Professor Shamim Kaisar, please start the session. Thank you.
Thank you, Dr. Mufti Mahmood. Am I audible?
Yes.
Good morning, good afternoon, and good evening. Thank you to each and every one of you for being here with us today in this technical session on application of AI and informatics in network security and analytics. I would like to thank organizer of AII 2022 for inviting me for sharing this session. As Mufti mentioned, we have 5 papers in this session. The first paper is paper ID 35, a novel approach to identifying DDoS traffic in the smart home network via exploration data analytics. I would like to request, one of the authors to present this paper.
Yes, you have to let me share my screen.
Yes, you can share your screen.
Okay. Thank you very much. Okay.
Just a quick reminder, please keep the presentation to 8 minutes with a few minutes for question and answer. Okay, thank you.
Okay. So good day, everyone. My name is Asma'u, and I'm presenting the paper titled A Novel Approach to Identifying DDoS Traffic in the Smart Home Network via Exploratory Data Analysis. So DDoS attack remains one of the most threatening attacks to the smart home network and IoT in general. Several solutions have been proposed to its detection, but there are still gaps, like being device user or attack centric. And there's the issue of having solutions which have the single packet inspection approach or too much parameters to process, which takes too much time. And then the issue of data suitability, where data is non-IoT or outdated data is used. So this paper is aimed at bridging these gaps by performing an EDA to visualize the normal and DDoS pattern and come up with a better approach to detect these attacks. So data was collected in a smart home environment consisting of a smart hub, motion sensor, smart plug, and a smart bulb. 3 types of DDoS flooding attacks were flooded to the target device. So it saturates the network. These are TCP, SYN, UDP, and ID and ICMP flooding attacks. And then attack and benign data sets were publicly sourced just for validation purposes to make sure the results and observations we arrived at on the private data is we have the same results in the public data set too. So EDA was carried out on these data sets. So certain network features were found to be greatly affected when the DDoS flooding attack comes in. So these network features are the protocol, the packet length, the sequence numbers, the TCP flags, and encryption. So these features were focused on and analyzed. So to start off with the protocol, as we can see, this is a normal pattern of the IoT device. We can see different colors. So each color denotes a different protocol. So this is a 1-minute traffic. So in the space of 1 minute, we have different kinds of protocol. We can see DHCP, DNS, ICMP, and the like. So this is the normal pattern. We have a combination of different protocols. The same with the packet length. In a space of 1 minute for both the private and public data, both on the right and the left, we have the length keeps going up and down. You have this randomized nature. It's not static. So the same thing for the sequence numbers. It keeps going up and down. It kind of has this varying nature. It keeps alternating. It's not static for the normal traffic pattern. TCP flags too in the space of 1 minute were found to be were found to come in a combination. You have the SYN flag, SYN ACK, each with an allocated proportion. It's very visible, we can see, because each color denotes a different TCP flag. So it shows how they vary in the space of a short time. So, but when we come to the attack traffic, this is the protocol pattern for both public and private data. We can see the protocol is told at one protocol. It doesn't change. So this is the indication of an attack. Plus encryption protocols are missing, which is abnormal because encryption protocols are one of the most dominant in the normal traffic pattern. The same thing for the packet length. It stalls at one length, even though few packets, 3 or 4 packets made their way through, legit packets made their way through the network while the attack is happening, but still the pattern is clear that the length became static. The same thing for the sequence number, it became static, though it even became just static at 0 and nothing more, which is unusual because it goes up to very high numbers, but when the attack comes in, it just goes static at 0. So the TCP flags too, if we remember, we have several combination of flags, but when the attack comes in, one flag becomes very dominant, which is the SYN flag in this case, because it's the one used for the attack. So it's the reverse, because the ACK flag was the most dominant in the normal pattern, but here it's the reverse, it becomes the SYN flag, and others are overshadowed, which is unusual. The same thing for the next attack. For the UDP attack, we have a static protocol and there are no encryption protocols. It's just a straight line for both data sets. The same thing for the packet length. There isn't that variation. It goes straight. You can see the same thing for the ICMP attack. Though for the packet length for the ICMP attack, it alternates between 2 lengths because this attack is a type of attack that works with pinging. So as it pings the device has to reply back. So this response comes with a different length while the request comes with a different length. That's why we're seeing 2 alternating lengths strictly, but still the randomized pattern is lost. So 3 observations were made from this EDA, which are feature variants. So we've seen how the protocols vary, the TCP flags vary, the packets length vary, like there's this randomized nature of a pattern, but this is lost when the attack comes in. This variant is lost, which signifies an attack. The next thing is the feature range, which we see the packet length falls within a very broad range, but this is lost. The same thing with the sequence numbers. They're stored at 0, so that range is also lost, which should raise a flag. The next and one of the most important things are the feature absence. So there are features which are normally present, but for some reason when the attack comes in, they get absent, like the TCP flags. Because if you remember when I was talking about the UDP and ICMP attacks, I didn't talk about sequence numbers or TCP flags because they were lost when those attacks came in, which is unusual because these are frequently present during the normal pattern, but these get absent. Plus encryption protocols to get absent. And even during the SYN attack, some of the TCP flags that are normally present were absent. So this should show us that the narrative should be changed from just focusing on the present or visible statistics. Rather, we should ask questions why certain things are absent, so as to get the answer. So this shows how important it is to ask why certain things are absent. So based on these observations, this detection approach was come up with. So you first define the target address, the MAC or IP address, and you specify the flow direction. So is it to or from the device? And then you set the threshold. Is it after every 20 packets or after every minute? So you do the checks, check if the protocol is told at one protocol or if there's that variation. You check the packet length too to see if that variation exists. And then you check for the sequence number. You first check if it's present or absent. If it's absent, then it's automatically an attack. The same thing for encryption. It shouldn't be absent for devices that use encryption. The same thing for TCP flags. Absence should be tagged as a malicious pattern. So by doing this, we correlate these logged flags and then carry on with a mitigation pattern. So this proposed approach has bridged some gaps, like it's not user attack nor device centric, because it's for a broad, you can deploy it regardless of the smart home user or the smart home device. It uses less redundant matrix, so it's a lighter weight version, plus less parameters are used to arrive at the decision, so it doesn't take too much processing power and time. And then it's practical in the sense that it doesn't employ the use of single packet inspection. So it's also like more efficient. So this is something I came across recently and I thought I should share, which is a similar approach we're using with regards to missing data that was used in the past. So during World War II, fighter planes would come back from battle with bullet holes, and the Allies initially sought to strengthen the most commonly damaged parts of the planes to increase combat survivability. So a mathematician pointed out that perhaps the reason why certain areas of the planes weren't covered in bullet holes was that the planes that were shot in certain critical areas did not return. So this insight led to the armor being reinforced on the parts of returning planes where there were no bullet holes. This wisdom was used beneficially, applied to the Sky Radar during the Korean War. This shows that the reasons why we are missing certain data may be more meaningful than available data itself. So we should listen to what is not being said rather than focusing on what is always present and visible. We should ask questions why things go missing. Because even in machine learning, it is a standard to kind of eliminate missing values or missing columns, which when you have the domain knowledge, you should ask questions why those things are missing. So to conclude, this paper did the EDA, and it's trying to change the narrative from just focusing on visible statistics and then encouraging to ask questions why other parameters that are normally there, why they are absent. And then I'm happy to let you know that this approach has been implemented and tested with regards to detection and also classification and covering zero-day attacks, so it was done in a two-way solution, both algorithm-based and machine learning-based, and we're having promising results. Thank you very much.
Thank you for presenting this. Dear audience, if you have any query, please do not hesitate to ask. Any question? Okay, I have a question. I mean,
Okay.
TCP flag sequence number.
Yeah.
And if the the network condition is worse, let's say too much traffic, in that case, the TCP flag sequence number, do you think this feature can help us to detect the attack?
Sorry, I didn't get the question. So you mean when the attack comes in?
Yeah. So the TCP, the TCP flag as well as the sequence number can also change due to the
yes,
the worst
exactly.
network condition, right? Yeah.
Yes, you can. Yes,
so
you can. Yes. So one thing is to if it's because we did the solution based on an algorithm and did a machine learning solution. So let's say we're using the algorithm-based solution. So you can say whenever you have TCP flags missing for 20 consecutive packets, then it should be flagged as an attack. Or when you have the SYN flag is dominant, so that should be also flagged as a TCP SYN attack, because it is not usually, you can't have that much of SYN flags in such a short period of time. The same thing for the sequence numbers. You can say if you have, let's say, 20 consecutive sequence numbers that are 0, then, or even 10, because it's not possible, then you should flag it as an attack, because the sequence numbers are always high numbers. They they have an incremental nature. So on the machine learning side,
so
too,
why you were saying only 20?
Pardon?
I mean, why you were saying only 20? it can be
So
19, can be 21, right?
Yes, so it depends on the threshold you set. You can set it at 10, you can set it at 20, or you can say after every minute. So it depends on. So on the machine learning side, you could say, you could avoid dropping missing values and say, okay, if TCP flags or sequence numbers are missing, then so use those as parameters. So when they get missing, then it should be flagged as an attack, not just to drop them.
Thank you so much. Thank you.
Thank you very much. Thank you.
So I would like to invite the next presenter, paper ID 79, indoor positioning and navigation using Bluetooth low energy and cloud service in healthcare perspective. I would like to request one of the author to present the paper.
Hello, assalamu alaikum, sir.
Welcome, assalam. Please present your work.
Okay, sir. Sir, is the screen okay?
Yeah. Yes, your screen is visible and you are audible. Please present your work within 10 minutes. Thank you.
Thank you, sir. Myself, my paper ID is 79 and the paper entitled Interpositioning and Navigation using Bluetooth Low Energy and Cloud Service in Healthcare Perspective. So myself, Shakib Nemizan, and my co-author, sir, Professor Sham Kaisar, sir, Shaimal Mamun, sir, Milon Bishas, Nusrat Jed Engineer, Mufti Mahmoud, sir, and Abzidin Adamov, sir. Okay, so next I'm moving to the main content. So first of all, I'd like to share what is interpositioning here. So interpositioning is a technology that assists in locating objects or people within a building. Then the term comes, what is BLE actually? So Bluetooth Low Energy is a low power wireless communication technology that facilitates short distance communication between smart devices. And additionally, it also saves the power. And cloud services refers to a variety of internet-based facilities. And basically, the services are intended to offer simple, low-cost accesses to applicants and resources without the demand for internal infrastructure or hardware. So all the components of cloud services monitored via cloud computing. And by combining all those technologies, it can be used to monitor and guide patients with neurological illness such as Alzheimer or dementia patients within the hospital premises. So this research describes a system for indoor navigation based on wireless sensors, a mobile health application as well, and Bluetooth beacons. And moreover, this study goes into great deal about how a mental health app interacts with the cloud-based architecture. So here the four major objectives here. So first of all, to build a framework for indoor positioning and navigation with Bluetooth low energy tags and cloud service. Secondly, to implement indoor positioning and navigation system using mobile application and cloud-based framework. Third of all, to evaluate the performance of the proposed system based on the case study. And at last, to compare the proposed interpositioning system with the SOTA, the state-of-art techniques. Okay. Now I like to compare with the related work and this research work. So mainly the related work worked via worked properly. I mean the many different methods and strategies as well as modern technologies have been offered for interpositioning and navigation, and they have implemented several approach and maybe like that probabilistic approach, KNN algorithm approach, neural networks, Wi-Fi fingerprinting, distance based filtering, trilateration algo, flips, fuzzy logic, and geometric path computation, semantic path filtering, BLE based or computer vision. But the gap found over here is that while the most systems consider the geographical coordinates of the interpositioning using BLE, Wi-Fi, or other technologies, but they never considered the user's physical and perceptual abilities. And second, not preference for routing, actually only the positioning they preferred, and mostly employ weights to compute the interpositioning in geographical topological layer. Okay, so on the contrary, comparing with the sort of our techniques, this proposed system simultaneously represents the interpositioning and navigation by using BLE beacons, and considers the user with the neurological disorder to assist them for decorous navigation and guidance. So the proposed model. So here's the hospital premises with patients. So a Bluetooth system to let patients route the hospital based on this. And when a patient enters the hospital perimeter, the mobile application or the app establishes a network between the hospital network and the patient. And finally, the patient can then select the desired destination to navigate within the hospital. Okay, elaborately in details next. So interpositioning, how the interpositioning works actually here. So first of all, the initial interior uh, if first of all, if we look at this diagram here, so uh, here are three BLE beacons cell, like cell A, cell B, and cell C, and these three BLE tags are transmitting their signals, and according to the patient's location, the highest RSSI, I mean the received signal strength indicator value, is the highest in the cell B. So the direction will flow according to this cell B. So here in details. So first of all, the initial interior positioning starts by catching the BLE node signals. So app will catch the BLE node signals, and the BLE node is shown to receive the RSSI from other BLE access nodes that are located in different places in this figure. And the BLE node then chooses the RSSI that is considered to be the strongest. Here the cell B is the strongest. After that, the system or the app sends the beacon ID and the corresponding RSSI value to the server side or the decision making side. And the server then analyzes with the signal and the RSSI value and sends the indoor coordinates as to the app, as well as the location to the reporting system. It also helps for the routing. So here the block diagram here. So first of all, the mobile user or the patients or the user will registered, and the registration will be here by the cloud-based Firebase. So then after registration, the user will select the place after where the desired destination he or she wants to go, and after that the app will catch the BLE signals and according to the highest RSSI BLE signals, the next decision will make. So the decision will make with two things after catching the BLE signal: where the user wants to go, and at right this moment, which signal is captured by the app. That means where he or she is in this right positioning. So within these two parameter, the next analysis algorithm will happen, and will show the routing. And some problem here where the crossover signals occurred here. So according to the received BLE signals, we sort the compared among the signals corresponding to their RSSI values, and only the app will catch the strongest tag value. So the other less power signal or less RSSI signal will be eliminated here. Okay, so next, how the registration process works. So the user add the actually a mobile number based OTP verification based registration. So user add a mobile number and sends the request for the OTP to the Firebase, and after a Firebase will send the app receives OTP, then app
Shaikh,
will
2 minutes. Last 2 minutes, Shaikh.
Okay, sir. Okay, sir. Then request for credential, and after that, the feedback send credential. So how the registration is processed here? Okay. Then if we look at the deployment database design here, so here the DevOps server or the server. So here the user registration, save place, and the user and the where the user wants to go. So these things are saved here for security purposes here actually. So if it's the system design, so here it seems like the block diagram. The user registration via the Firebase. After that, selects place. Then the all is saved in the cloud database. Then after the BLE access node received, compare the signals. The highest according to the algorithm analysis, the direction is shown to the user app. Okay, then algorithm analysis here to avoid crossover signals. Here the main thing is that to compare the received signals and only catch the highest RSSI values here. And algorithm analysis for navigation, like user wants to go A, and her or his receive signal is T. So according to this parameter, then our app will decide that to move to the right here, and the rest of the codes are like in the same way like that. And the algorithm analysis with the implementation of complete algorithm. So registration, the selection, upload desired place to the database, Bluetooth based, then nearby BLE signal, then analysis signal with these two parameter, receive signal and desired location, and then the routing will happen to the desired destination. And performance analysis based mainly. So we have implemented with this 4 BLE tags in indoor premises area. So actually it works fine. And first of all, the represents the landing page and the app registration with the mobile phone number, then selection, and then the routing here is happening D section. So last of all, so actually this research describes the design, implementation, and assessment of app-based indoor locationing system with BLE technology, depicts a system of internal navigation that can be used for monitor and track individuals' neurodegenerative disorders like Alzheimer's, and enables real-time remote monitoring for primary medical care for the family and clinicians. And Alzheimer patients will benefit from the planned interior navigation system, which will assist them in navigating in the building. And I'd like to make the acknowledgements to the ICT division, Information Communication Technology of Bangladesh, and also the Ministry of Post Telecommunication and Information Technology, Governments of the Republics of Bangladesh, and also the IIT, Institute of Information Technology, Jahangirnagar University. That's all, sir. Thank you.
Dear audience, if you have any question, please ask Shaik. Any question or any suggestion? Okay, thank you. Thank you, Shaik, for your presentation. Let's move to the next presenter. This is paper ID 96115, evaluation of GSR signal feature for emotion recognition. I would like to request one of the authors to present this paper.
Okay, I've recorded my presentation
Aisha, yeah.
in advance, but I cannot share because the current presenter is there.
Shaik, can you unshare your screen? Shaik?
Yes, sir, yes, sir, yes, sir, yes, sir. Sorry.
Okay.
Aisha, you are requested to finish your presentation within 10 minutes.
All right, noted. Thank you.
A very good evening I bid to all members of the conference, the organizers, invited speakers, and fellow authors. My name is Aisha Amelia, and I am one of the authors for the paper Evaluation of Galvanic Skin Response Signal Features for Emotion Recognition. So my presentation will be divided into 4 parts, which are introduction, methodology, results and discussion, and lastly, conclusion. Now let's begin with emotion recognition. Emotion recognition has been applied in various fields, especially in medical field, for disease identification. In the early years, research conducted on emotion recognition had focused on analyzing body language, facial expressions, and speeches. However, these factors may be inefficient as they can be controlled externally, which indicates that an individual can hide their true emotions. Hence, the use of biosignals such as the galvanic skin response are more effective, as it involves responses in the autonomic nervous system, which is referring to the control system of the body that primarily executes unconscious bodily function. The process has 3 main steps, with the first one being pre-processing, followed by feature extraction, and lastly classification. In a previous study, we've compared the recognition rates achieved by existing studies that have conducted emotion recognition on GSR signals based on the number of stimulus and subjects used and the different feature extraction methods and classifiers used. This became a guide for us in proposing the methodology for this project. Galvanic skin response, or GSR for short, can be further grouped into 2 main components, which are skin conductance level and skin conductance response. SCL is referred as the tonic level, which represents the skin conductance baseline, meanwhile SCR is referred as the phasic level, which represents the reactive rapid changes, which is mostly event-related. Emotions are commonly represented using the valence arousal bipolar model. The valence represents the quality of an emotion, whether the emotions are positive or negative. Meanwhile, arousal represents the intensity or the quantitative activation level of the emotion. In this paper, we focus on the evaluation of features extracted from the GSR signals, where 4 emotion classes as listed below are investigated. So for the methodology, the MATLAB software was used to analyze the GSR signals. The applications were provided by the software itself, which are the Signal Analyzer, Diagnostic Feature Designer, and Classification Learner. Meanwhile, the GSR signals were obtained from the Amigos dataset, which is the publicly available multimodal dataset. Figure shown is a flowchart that describes the process of emotion recognition used in this paper. So we first started off with the data acquisition from the Amigos database. Then we proceed with the first main step, which is pre-processing the GSR raw data signals, which involves downsampling and smoothing filter. Then we proceed with organizing and labeling the pre-processed GSR signals to the respective class and combine them into a single dataset. Then we proceed with the second main step, which is feature extraction, where we extracted features in time domain and frequency domain. And last but not least, we proceed with the classification of the extracted features using the SVM classifier. The features extracted in time domain can be further divided into 3 types, with the first one being basic statistical values, where we extracted the standard deviation, root mean square, and mean, followed by the higher order statistic, where we extracted skewness and kurtosis, and last but not least, impulsive metrics. As for the feature extraction in frequency domain, the Welsh power spectral density method was selected, as it has shown satisfactory accuracies in existing studies. Commonly referred as the weighted overlap segment averaging method, this method returns the estimation of power spectral density of the input signal by using the averaging estimator of Welsh overlapping segment. The features extracted in this paper are spectral peaks, peak amplitude, and peak frequency. Besides this, feature selection using the one-way ANOVA method was conducted to observe the significance of the features extracted. The ANOVA is the analysis of variance, which primarily involves the comparison of mean values of groups that are mutually independent groups. It studies the significance level differences between groups in the dataset. Significance level is defined as the maximum acceptable error range that can reject the null hypothesis. So in this study, it involves 4 groups. So the null hypothesis will be the population means of these 4 groups are the same. Meanwhile, the alternative hypothesis is at least one of the population mean among these 4 groups is different. Hence, when the mean values of any 2 groups among the 4 groups are different from each other, the null hypothesis is rejected. For the classification, a 5-fold cross-validation method was applied, where 80% of the data is trained while the remaining 20% is for the test. In this study, the classifier selected is support vector machine. It is observed to be the most common and best classifier for the classification of GSR signals. Table below shows the parameters used for the classification. To compare the performance results, the results obtained from the classification were compared with the prediction of affective states that was originally obtained by the authors of the Amigos database. The performance results are measured in terms of accuracy and is calculated using the equation shown. Moving forward to the results obtained in this paper. So we first have the summary of extracted features, where a total number of 16 features were extracted in time domain and frequency domain altogether. Figure shown is a chart computed using a simulation in MATLAB that has ranked all the extracted features by importance using the ANOVA method. From the top, it represents the most significant feature, meanwhile the bottom represents the feature with the lowest significance level. From here, we can see that the most significant features are the frequency domain features, meanwhile the time domain features have much lower significance levels. The overall accuracy of features extracted were evaluated based on the types of features, number of features, and the importance of the features by creating several subsets. From here, we can see that the highest accuracy is achieved by the subset of the top 7 of only frequency domain features with the accuracy of 83%. Subsets that consist of only frequency domain overall show significantly better accuracy compared to time domain features. The lowest accuracy rate achieved by using only frequency domain is 72%, which is significantly higher when compared to the lowest accuracy achieved by using only time domain features, which is 60.2%. It was observed that increasing the number of features from 5 to 7 for the frequency domain only subsets increases the accuracy rate. However, increasing it from 7 to 9 lowers the accuracy rate. A similar pattern can be observed for the time domain only subsets. From 3 to 5, it increases the accuracy rate. However, when increasing it from 5 to 7, lowers the accuracy rate. For when both time and frequency domain features were used, the first subset shows better accuracy performance, which is 77%. Increasing the number of features from 5 to 16, which is the total number of extracted features, increases the accuracy to 79.5%. Moving on to discussion. So the first main findings from the study is greater number of features used for emotion recognition does not guarantee higher accuracy rate. This is based on two observations. So firstly, when the number of features were increased, most of the subset had their recognition rates decrease. However, it was also observed that too small of a number also yields a low recognition rate. This leads to the second main finding, which is the significance and the type of each feature has a bigger effect on the recognition rate. Based on the figures shown earlier, it is shown that the frequency domain features dominate the top spot in terms of importance. Meanwhile, most of the time domain features are observed to be in the lower spots. From these observations, it can be concluded that using features using more significant yields higher recognition rate. Table shown summarizes the comparison between the highest average accuracy rate achieved for this study and existing studies that have used the same GSR signals from the AII2022 database. The method applied by Shukla and co-authors is similar to this study, where features in time domain and frequency domain were extracted, except the authors had also extracted features in time frequency domain, specifically Mel frequency Steptrose coefficient, discrete wavelet transform coefficients, and stationary wavelet transform features, which totals up to 621 features altogether. The study was able to achieve a high accuracy rate of 85.75% and 83.9% for arousal and valence respectively. In the recent years, more studies had conducted emotion recognition using convolutional neural network. For instance, Santamera, Granados, and co-authors had applied the deep learning approach using deep learning convolutional neural network, which results in an accuracy rate of 75% and 71% for valence and arousal respectively. Besides this, a study by Dar and co-authors had proposed a long short-term memory method and one-dimensional convolutional neural network architecture and was able to achieve an accuracy rate of 63.67%. The study by Zhao and co-authors had also proposed a multimodal model for emotion recognition that applied a three-dimensional convolutional neural network as well as one-dimensional convolutional neural network and was able to result in an accuracy rate of 84.69%. Meanwhile, in this project, the highest classification average accuracy achieved was when only the top 7 frequency domain features were used, which was 83%. This shows that this study was able to achieve high accuracy that is comparable with existing studies that have used the same GSR signals from the AII2022 database. Furthermore, the study was able to achieve higher accuracy compared to studies by Santamera, Granados, co-authors, and Dar and co-authors without using the complex convolutional technique. So the main contribution of the paper is the evaluation on the features extracted from the GSR signals, where we applied the one-way ANOVA method and compared truly the accuracy recognition rates calculated. The main findings of the study were critically discussed, hence the performance of the extracted features was successfully evaluated based on features' importance and significance from the average accuracy. A limitation of this research is the accuracy performance achieved may not be as optimum as presented due to several factors such as the applied preprocessing and feature extraction techniques may have not been conducted optimally and because of the selection of classifier. Thus, further exploration is encouraged. Furthermore, different classification methods such as KNN and decision tree classifiers can be applied to investigate the efficiency of extracted features. In addition, more types of features should be explored. And that marks the end of my presentation. Thank you very much.
Thank you.
Thank you, Aisha. Dear audience, do you have any question or suggestion? Any question? Yes, Dr. Mufti Mahmood.
I have a curiosity. It's not really a question. I have a curiosity, and I would like to request her to shed more light onto that. So, what are the specific challenges that you actually faced in this emotion detection process, and how do you think that is something can be overcome? So, if you could provide some more details on that, it would be really appreciated.
Challenges. Okay. First of all, existing papers that conducted emotion recognition specifically on GSR signals is still lacking. So they usually conduct emotion recognition using a multimodal set where they use, besides GSR, they calculate the recognition rates together with other signals such as EEG, EMG, and so on. So it was quite challenging to understand and evaluate how exactly these features represent a certain emotion. And I think that's one of the challenges also. And also implementing, simulating the features itself on the MATLAB software was also challenging. So I think my paper itself actually helps in creating a platform where readers can try and guide them in using the MATLAB software itself to guide them in conducting emotion recognition using software, using MATLAB.
Okay, thank you. Do you think that, well, any other type of multimodal data might help in the identification of more appropriate features representing each of the emotions?
Pardon, can you repeat the question?
I'm saying that, well, do you think that if you are having other multimodal data to be included in the system, and from those multimodal data, if you can have some more features, do you think that you can find the appropriate biomarker to each of these emotions? Do you think it is possible?
Yes, it is possible. Yes, because there actually have been studies that conducted. They include all these features of different signals into one, for example, a network to identify the emotions. So yes.
Okay, thank you very much. Thank you. Yeah, nice work.
Thank you.
Thank you.
Thank you.
Thank you, Dr. Mahmood. Now let's move to the next presentation, paper ID 89. The title of the paper is Identification of Crown and Ramp in the First Trimester Ultrasound Images Using Deep CNN. I would like to request one of the authors to present this paper.
Yeah, just 1 second. Sorry, 1 second.
Yes, Sam, go from beginning. Yeah.
Yeah. Well, sorry, 1 second. Sorry.
And then, yeah, exactly. Change it from there. Right.
Sorry, is it duplicate slideshow?
The top one. Swipe presenter view and slide view. Yeah.
Yeah.
Yeah, that's it.
Okay.
Yeah.
Yeah, thank you. Sorry about that. Welcome to the presentation on the identification of crown and rump in first trimester ultrasound images using deep convolutional neural networks. To provide a background into this problem, it is important to understand the importance of first trimester ultrasounds. And first trimester ultrasound scans are the first scans that take place in early pregnancy and are used for different purposes, including determining the number of fetuses and determining the gestational age, which is the focus of this paper. The first trimester ultrasound scan is the earliest time that the gestational age can be estimated and is highly accurate and has been called the best fetal parameter. The gestational age is important to estimate the age of the pregnancy and the CRL measurement. The CRL measurement is the crown to rump length, and that's what's used for the measurement. So machine learning can be applied to this problem to help obstetric practitioners with an accurate CRL measurement, and this will then help inform them of the optimal timings of any necessary interventions that are needed for the health and well-being of the pregnancy. A machine learning system would allow for inter-observer variation to be reduced, and this variation creates problems for the practitioners, as any variation in the measurement of the CRL can carry serious complications to the fetus's health. So the aim of the paper is to identify the crown and rump regions in ultrasound scans to help to reduce inter-observer variation. A machine learning pipeline has been developed utilizing different models, and this included developing an image segmentation model to segment the fetus away from the background of the ultrasound scan, provide a binary classification of good and bad images from the output of the segmentation model for suitability of crown and rump identification for obstetric practitioners, and then to identify the crown and rump regions in the segmented image. And all of these aspects will help to reduce the effects of inter-observer variation in the measurement of the CRL. The dataset that was used for the paper was collected from the Southend University Hospital, and proper and valid approval was granted to use the dataset for the purpose of this paper. The dataset has been used in one paper previously called the Classification of First Trimester Ultrasound Images Using Deep Convolutional Neural Network by Singh et al. So the dataset that we used different formats of image files, including JPEG and TIFF, and TIFF is used as it is a prerequisite of a unit model. A machine learning pipeline was developed using 3 different models, and this can be shown a bit more clearly on the flowchart here. A unit model was used to segment the fetus away from the background of the ultrasound images. The pipeline starts with the inputted image being passed through the unit model. The unit model will then produce a segmented fetus, which is then passed through a VGG16 classifier that has been hypertuned to improve accuracy. And this will return a value depending on if the segmented fetus would be a good or bad image for crown and rump region identification. If an image is deemed as a good image, it is then passed across to the ResNet34 model for the crown and rump coordinates to be identified. If it is a bad image, then the coordinates are not calculated, as the image taken by the practitioner is not suitable for CRL measurement. The unit model is used to segment the fetus. The unit model was first developed by Ronberger, and its application across the medical industry has been successful for a range of image segmentation problems. The diagram below documents the structure of the model and the process that the inputted image goes through before being outputted as a ground truth mask. The model consists of an encoder and decoder path. The encoder is on the left-hand side of the diagram and consists of repeated applications of 2 3x3 convolutions, followed by a ReLU and a 2x2 max pooling operation. Through each downsampling step, the features channels are doubled and the spatial dimensions are halved. The decoder path consists of upsampling the feature map, which is followed by a 2x2 convolution to reverse the steps of the encoder path. Following this is a concatenation with the crop feature map from the contracting path, and then 2 3x3 convolutions, followed by a ReLU layer. The final layer is a 1x1 convolution that maps the channels to the classes and returns the ground truth mask that will be used to segment the fetus from the inputted image. The VGG16 and ResNet34 models were identified through comparison of the transfer learning approaches as the most suitable models, the classification of segmented images, and the identification of the crown and rump regions. As a part of the selection process, the VGG16 classifier was selected as the most appropriate transfer learning model due to higher performance when compared to DenseNet121, ResNet50, and Inception v3. The classifier was also compared to the state-of-the-art methods to evaluate its performance. The state-of-the-art methods used the same architectures as we evaluated and similarly classified first trimester ultrasound images into good and bad images. This evaluation can be shown in the bar chart on the slide and is included within the paper. VGG16, ResNet50, and Inception v3 were all compared with this other paper to show a higher increased accuracy for VG16 classifier across training and validation accuracy. The ResNet34 model has been developed through the FastAI library. Finding research that specializes in finding 2 coordinates with an image was limited, but the library allowed for the model to be trained and hypertuned effectively, as well as to plot 2 coordinates on an inputted image. The model took in JSON files with coordinate information as the labeling data and is trained to recognize the crown and rump in each first trimester ultrasound image. Issues arise with some reliability issues among different orientations of the segmented fetus and due to the low to noise aspect ratio present in ultrasound images. Once identified, the coordinates are scaled and plotted onto the segmented fetus in blue and then displayed to the user. Throughout the background research that was conducted, it was present that image segmentation within the medical industry was the preferred practice to obtain the most accurate results. In this paper, we used a unit model to perform this segmentation, but other types of segmentation have been just as successful. To prove that the research was accurate for this case, it was important to evaluate the performance of segmented versus unsegmented images for the crown and rump identification. As can be shown in the diagrams below, the segmented data performs better across training loss and validation loss, showing that segmented data helps when learning to identify the crown and rump regions. This paper successfully creates a machine learning pipeline that reduces inter-observer variation by providing obstetric practitioners with new concepts for them to view first trimester ultrasound scans. Automatic image segmentation and the identification of crown and rump regions applied to first trimester ultrasound images are important novel concepts to this area of the medical industry. However, further improvements can be made to this system. Further future works to this paper can help to improve the accuracy of the model, which would allow a reliable system that obstetric practitioners can depend and rely on for the estimation, for the measurement of the CRL and the estimation of the gestational age. To improve the accuracy of the model, a larger data set to train and test models would be needed. And in addition to this, if the labeling of the ground truth masks and the crown and rump coordinates were carried out by medical professionals, we would ensure that the model would be held to higher standards and ran by experts of the medical field. Due to a lack of scaling data available in the data set, we were unable to actually calculate the crown to rump length from the coordinates identified. In a data set in the DICOM format would allow this to be calculated and allow for the end-to-end precision that would be needed for obstetric practitioners. Thank you.
Thank you so much for your nice presentation. Dear audience, if you have any suggestion, queries, please feel free to ask. I have a question. I mean, let's say, for segmentation, for the real-time analysis, the segmentation of the region of interest will be challenging. What is your opinion on this issue?
Sorry, could you repeat that question, please?
I mean, let's say you are analyzing this one in real time. You have already mentioned in your future work, you'd like to implement this system in, for analyzing in real time, right?
Yeah.
So I mean, the selection of region of interest and segmentation will be challenging if you do this job in real time. So in your opinion, what are the challenges for solving this issue?
Of course. So issues with real-time data would mean that the real importance of a practice of how the practitioners would take the ultrasound scans. Issues arose in our research when the fetus was orientated in a different way. If the model was trained accurately across a larger data set than we had available, I would believe that it would be able to really learn from that and be able to learn from that and be able to account for a lot more different data. Issues with the real time is definitely a case and definitely would be needed to be thought about, as classifying an image into good and bad isn't possibly enough categories as it just being a binary classification. But that's definitely something that would need to be considered before this system could be rolled out further.
What is the size of your image? Size of the image? I mean,
so
after segmentation,
yeah. So it's 256 by 256.
So do you think, I mean, by this one, we will get the better accuracy? 256 into 256. Because,
Yeah.
you know, I mean, the medical images, the pixel density of the medical images is too high. So
Okay.
do you think with this 255 and 256 by 256 is enough for, I mean, accurately classify the images?
Yeah, I really understand your point there. Definitely for use on the front line and to really rely on the system, that would definitely be something that would need to be improved, really, just to get in the most accurate data. So I think, yeah, so with an increased image size and increased pixel density as well, we would definitely see improvements to the model.
Thank you so much for your presentation. So let's move to the last presentation of this session, paper ID 90, a hybrid deep learning system to detect face mask and monitor social distance. I would like to request one of the authors to present this paper. I think Lutfun Nahar is present here.
So I think Nadia will present on behalf of. She is there.
Okay, thank you.
Good evening, sir. If I have to stop video or not, can you please suggest me?
I mean, please share your presentation. And
yes,
if you are comfortable, yeah.
Thank you, sir.
Shadat sir.
I think she has some problem. That's
She has joined already. Nadia, you are not audible.
Nadia, you are not audible. We cannot hear you.
Nadia, you are not audible. Nadia, please check your microphone.
Well, given that our keynote speaker is already here, and we are actually at the time of the keynote speech, Nadia, if you don't mind, will you be available to present after the keynote speech? Would that be okay?
Yeah,
so we can have
Professor Shadat, sir.
We can have the keynote, and after that you will be able to present. Would that be okay?
I think Mufti, this is okay.
So in the meanwhile, she can
since our
the problem exactly. Yeah.
yes.
Okay, so Professor Shamim, please conclude the session, and then we'll move to the keynote session. Yes.
Thank you. All the presenter for presenting your work. So let's move to the keynote session, and thank you all the audience for joining this session, and thank you so much. Mufti.
Thank you very much, Professor Kaisa, for chairing the session. And yeah, well, it gives me immense pleasure to introduce the audience to the second keynote of the day. And today, as keynote speaker among us, we have one of the greatest scientists in the field of optimization, meta-heuristics, and that is Professor Carlos Coelho. And Professor Coelho received his PhD in computer science from Tulane University in 1996. And his research was mainly focused on the design of new multi-objective optimization algorithms based on bio-inspired meta-heuristics, and which are popularly known as evolutionary algorithms, which is an area in which he has made pioneering contributions. He currently has more than 550 publications, including more than 160 journal papers and 50 book chapters. He has published a monographic book and has edited 3 more books with publishers such as World Scientific and Springer. He has supervised 22 PhD theses, including 3 in Argentina, and 48 master's theses, including 1 in France. Several of the PhD theses that he has supervised have received awards in national competitions. He has also received, with his students, several best paper awards at different international conferences. He is also the only Latin American who has been awarded twice the Outstanding Paper Award of the IEEE Transactions on Evolutionary Computation. His publications currently report over 62,000 citations in Google Scholar. According to Scopus, Dr. Coelho has got 22,725 citations, excluding self-citations and citations from all his co-authors. His current H-index is over 95, according to the Google Scholar, and 67 according to Scopus, and 63 according to the ASI Web of Science. In the Shanghai rankings, global ranking of academic subjects in 2016 developed by Elsevier, he appeared as one of the 300 most highly cited scientists in the world in computer science, occupying the first place in Mexico. He has received several awards, including the National Research Award in 2007 from the Mexican Academy of Science in the area of exact sciences. In 2009, Medal to the Scientific Merit from Mexico City's Congress, the Ciudad Capital Huberto Castillo 2011 Award for Scientists under the age of 45 in Basic Science, the 2012 Scopus Award, the Mexico's edition, for being the most highly cited scientist in engineering in the 5 years previous to the award, and the 2012 National Medal of Science in Physics, Mathematics, and Natural Sciences from Mexico's presidency. And this is the most important award that a scientist can receive in Mexico. He also received the Luis Elizondo Award for the Tecnológico de Monterrey in 2019. Additionally, he is the recipient of the 2013 IEEE Kyo Tomiyasu Award for pioneering contributions to single and multi-objective optimization techniques used in bio-inspired meta-heuristics. Of the 2016, the World Academy of Sciences Award in Engineering Sciences, and of the 2021 IEEE Computational Intelligence Society Evolutionary Computation Pioneering Award. Since January 2011, he is an IEEE Fellow, and he is currently the Editor-in-Chief of the IEEE Transactions on Evolutionary Computation. He is full professor with distinction at the Computer Science Department of the National Polytechnic Institute of Mexico in Mexico City, Mexico. So, well, it is just a snapshot of the huge achievement that the Professor Coelho has here. And well, without taking much due, we all are very eagerly waiting to hear to the keynote. Professor, to you.
Thank you. Thanks for the invitation and for the nice introduction. So let me share my screen. Yeah, I think you should be able to see my slide in there, right? Okay, so this talk is about an area in which I have been working for a long time, since 1994, which is called evolutionary multi-objective optimization. And the way I organize the talk is I will give some generalities about the field very briefly. And in the second part, I will discuss a little bit the issues related to reproducibility in this area, which at the very beginning when it started was a serious concern. And over the years, particularly I will say in the last 5 to 10 years, it has significantly improved. So I will talk a little bit about that. How was this transition done in the field? So first, in case you're not familiar with multi-objective optimization problems, the idea in these problems is that I have 2 or more objectives that I want to optimize simultaneously, but at least some of these objectives are conflicting with others. So this is a very simple example. Let's say I want to design a bridge. If I want to optimize the design of this bridge, there are several possible objectives. 2 which are very obvious are to maximize safety, because there will be cars and people passing over the bridge, and I want to minimize cost. These 2 objectives are conflicting, because if I want to increase the safety of the bridge, I have to make the bridge more rigid, to put more steel, more concrete, and this increases the cost. If I want to reduce the cost, then I have to sacrifice some of these materials. I have to reduce materials. I have to increase the speed of construction, and all of this may compromise safety. So this is a good example, because in these problems, because of the conflicting nature of the objectives, there is no single solution, as we will see later on. So this is the formal definition. Instead of having two objectives, we have K. Instead of having one objective, we have K objectives where K is greater or equal than 2. And we may also have constraints, both inequality or equality constraints. So the first issue in multi-objective optimization is how do we deal with optimality? What will be the notion of optimality? In global optimization, is very intuitive that the optimum is the best possible solution in the search space. But in this case, since we have conflicting objectives, it's not so obvious what will be the best solution. So actually, there is more than one definition of optimality, but the most popular, which is the one we use in this field, was originally proposed by this guy, Francis Isidro Edgeworth. He was a professor at Oxford University. And it was introduced in 1881 in his book, Mathematical Psychics. This notion refers to finding the best possible trade-off between two objectives. However, it was Vilfredo Pareto, an Italian economist, who managed to generalize this notion. But it has to be said that Pareto was not aware of Edgeworth's proposal, so he rediscovered, in a way, the same definition. But since he was able to generalize it for any number of objectives, he is normally given the credit for this definition of optimality. In his book from 1896 called Cours d'économie politique, which was published in French, he used the term ophelimity. And over the years, the term started to be called Pareto-Edgeworth optimum, and finally Pareto optimum. It's not very common today that people use Edgeworth's last name, although it's a bit unfair because Edgeworth was the original guy who proposed the definition. So Pareto optimality is defined in a very simple way if we assume that all the objectives are being minimized, and this is a reasonable assumption because it's always possible to transform maximization into minimization. Then we say that a vector of decision variables which is feasible, that's what this means, the F, that means it satisfies all the constraints of the problem, is Pareto optimal if there does not exist another feasible solution such that it satisfies these two conditions, is less equal for every objective and strictly less for at least one. In words, this definition says that a solution will be considered Pareto optimal if it's not possible to improve one objective without worsening another. So it's very simple, but as we have conflicting objectives, of course, this is going to generate a set of solutions, not a single solution. This set in the decision variable space is called the Pareto optimal set. And the solutions in this set are said to be non-dominated. And the image, that is the objective function values from the Pareto optimal set, is called the Pareto form. These are very common terms we use in this field, which is not necessary to understand the rest of my talk, but I just wanted to introduce them because I may mention some of these terms later on. So first, obviously, multi-objective optimization didn't originate in evolutionary computation. It started in mathematical programming and operations research in the 1970s. In that regard, I can say that just referring to nonlinear multi-objective optimization, because we may also have linear or combinatorial multi-objective optimization. In nonlinear multi-objective optimization, there are more than 30 families of algorithms available for solving multi-objective optimization problems. So the question is, why do we need evolutionary algorithms or meta-heuristics at all? The reason is that these techniques that were developed since the 1970s, they have several limitations. The main ones, I will say, are two. One of them is they are not very general in the sense that they require a specific information about the problem, for example, the first derivative of the objectives and the constraints. And also, they don't work in several situations. For example, if the Pareto form is disconnected or is non-convex, or it has any sort of discontinuity. Additionally, there is another issue. These algorithms are very fast, because they operate with a single solution at a time. However, there is no guarantee that running the algorithm several times with different starting points, the final solutions that we reach is different from one that we found before. So if we want to generate several solutions, it may require a significant computational effort. We have to run the algorithm many, many times. So using evolutionary algorithms was something that looked natural at a point in the history of evolutionary computation, because evolutionary algorithms have peculiar characteristics that made them very suitable for multi-objective optimization. But before getting to that, very briefly, in case you are not very familiar with evolutionary algorithms, I can say that these are stochastic search techniques which are inspired on the principle of survival of the fittest from Charles Darwin. And they were developed originally in the 1960s. There are three main types of evolutionary algorithms. Genetic algorithms is the most popular, proposed by John Holland in 1962. Evolution strategies developed by Ingo Reichenberg and Hans-Paul Schwefel in Germany in 1965. And evolutionary programming developed by Lawrence Vogel in 1966. All these techniques share one common aspect. They all were designed for solving problems using random numbers and trying to simulate the evolutionary process during their execution. So the way in which they operate is described in this slide. This is relatively simple, I can say. We start with a set of solutions which are normally generated randomly. This is called the population. And each element in the population encodes all the decision variables. Each individual encodes all the decision variables of the problem. Then we have to evaluate each individual in terms of their fitness value. The fitness is a normalized version of the objective function, whatever it is that we want to minimize or maximize. And then the individuals with the highest fitness will have a higher probability of being selected. We select individuals by pairs, and these are called the parents. The parents are recombined, and then the offspring or the children produced by these parents are mutated. And this procedure is repeated several times until reaching some criterion of convergence, which could be maximum number of iterations. We use the term generations instead of iterations, or until diversity is lost. That means solutions are no longer different. We are generating over and over again very similar or identical solutions. Now, how is that evolutionary algorithms are modified to deal with multi-objective optimization problems? First, before getting to that, there are two main changes we have to introduce. But why is that they are suitable? They are suitable for also two main reasons. One is that evolutionary algorithms operate on a set of solutions, not a single solution at a time. So this means that if we properly manipulate the population, we should be able to generate several elements of the Pareto optimal set in a single execution of the algorithm. So this is an important advantage. The other advantage is that evolutionary algorithms are very general in the sense that they require very little specific domain information, information about the problem. And they are also less sensitive to the shape and the continuity of the Pareto front. Even if the Pareto front is non-convex, if it's disconnected, this doesn't affect seriously the performance of the evolutionary algorithm that is solving a multi-objective optimization problem. So this field started in 1985 with an algorithm called Vega, the vector evaluated genetic algorithm proposed by David Schaefer. And from 1985 up to the early 90s, this is what I call the old days of the field. There were a number of approaches that are very naive, very simple, that were introduced by several researchers. For example, linear aggregating functions in which we just add up all the objectives into a single scalar value. The objectives may have a weight if they are normalized. And then we transform a vector optimization problem into a scalar optimization problem, which is something an evolutionary algorithm can easily process because they are designed to be scalar optimizers. Other methods like, for example, lexicographic ordering, in which objectives are processed in a particular order, one at a time, and so on. There were several very simple, naive, I will say, rather limited techniques developed during this time. Epsilon constraint is a technique that transforms the multi-objective optimization problem into several single-objective optimization problems that are solved sequentially. So this is computationally expensive, and it requires some information about the problem. Target vector approaches, these are non-linear aggregating functions. In this case, instead of adding up all the objectives, what we do is to minimize the differences between the actual objective function values and the target defined by the user. And by minimizing these differences, we should be able to deal, for example, with non-convex Pareto forms, which is something that linear aggregating functions cannot do. However, target vector approaches require to have an idea of what we call the ideal vector. That would be the best objective function values for each objective if considered separately, which is information we don't normally have. It's possible to obtain it, but it comes with a computational cost. Then in the early 90s, researchers in evolutionary computation start to pay attention to multi-objective optimization, and a number of algorithms are developed. So we have, for example, Fonseca and Fleming's MOGA that was introduced in 1993. Kaljamoy's NSGA, the non-dominant sorting genetic algorithm, introduced in 1994, and Jeffrey Horn's niche Pareto genetic algorithm, MPGA, introduced also well, it was introduced in a technical report in 93 and in a conference in 94. All these algorithms were derived based on an idea, which is a sketch, because there is no real algorithm, it's just a discussion, in the famous book from David Goldberg on genetic algorithms that was published in 1989. Then, in the late 90s, the research conducted in EMO, in evolution multi-objective optimization, started to get more sophisticated. Several researchers started to develop more elaborate, more, I will say, well-designed algorithms. So we have, for example, the strength Pareto evolutionary algorithm developed by Eckhard Sitzler from ETH Zurich, which was published in the IEEE Transactions on Evolutionary Computation in 1999. It was very popular for many years. Then NSGA2, that was originally introduced in the year 2000, but the journal version was published in the year 2002, and it was also very successful. Actually, NSGA2 was one of the first, I will say, highly competitive multi-objective evolutionary algorithms whose source code was released in the public domain. Then there were many others, the Pareto Archive Evolution Strategy, the microgenetic algorithm for multi-objective optimization, and so on. Many others, most of which have been forgotten. People never use them, and they don't use them right now, of course. Then from the early 2000s to today, we have the algorithms that people normally use these days. So we have, for example, MOIA-D, the multi-objective evolutionary algorithm based on decomposition, which was introduced in 2007, is very popular today. We have a family called indicator-based approaches, from which the first algorithm was called the indicator-based evolutionary algorithm, introduced by Sitzler in the year 2004. But the most popular has been SMS-IMOA, which is a variation of NSGA2, in which instead of using the crowded comparison operator from NSGA2, they use a performance indicator called the hyperbole. And I will get to that in another slide. And then we have, of course, the NSGA3 that was introduced by Kaljamoy in the year 2014. These algorithms, they are all very popular. At least MOIA-D has the source code available in the internet. That's not the case of NSGA3, and that's not the case of SMS-IMOA. The indicator-based evolutionary algorithm has its code available in GitHub. Okay, so in general, the difference between a multi-objective evolutionary algorithm and a traditional evolutionary algorithm is in two components. First, the selection mechanism is no longer based on fitness. is based on Pareto optimality or something equivalent to Pareto optimality. Indicator-based algorithms, in theory, should not rely on Pareto optimality, but on a performance measure. And I will explain that in another slide. The second component is something we call the density estimator. The density estimator is a very important mechanism which is responsible for maintaining diversity and therefore for keeping the algorithm from converging to a single solution. This is the mechanism responsible for keeping several solutions that are different, for example, in decision variable space, in the same population. Without this mechanism, because of a stochastic noise, because this is a stochastic algorithm and random numbers in a computer are really pseudo-random, all solutions will become identical if you run the algorithm for a very long time. So to avoid this, we need to block this process by using this so-called density estimate. Now, there are three main types of algorithms that are in current use today. I will go very quickly with one slide for explaining each of them. We have the Pareto-based, decomposition-based, and indicator-based. Pareto-based are the old ones that I mentioned first, in which selection is based on Pareto optimality. All of them adopt some form of non-dominated sorting, or is also called Pareto ranking. It's a ranking method that gives priority to solutions that are non-dominated, because these are the Pareto optimal solutions, and they get the same selection probability. In terms of fitness, they will get the same fitness, so that when selecting, they all have the same probability, and solutions which are dominated, which are the bad solutions, get a lower fitness or a lower probability of being selected. The density estimator, we have many. I have another slide in which I will mention a few. The main limitation of Pareto-based algorithms is scalability. As we increase the number of objectives, very quickly these algorithms don't work properly, because the number of non-dominant solutions increases exponentially with the number of objectives. So when reaching 4 objectives, we already have many solutions. Why is this bad, to have so many non-dominant solutions? It's bad because then the selection is no longer biased. For the selection to be biased, we need to have both dominated and non-dominant solutions. If everybody is dominated, then they are all equally good. And we are basically randomly selecting solutions. So this is bad. There are ways around this. For example, we can increase the population size, but since this increase is exponential, most people don't do that. The other possibility is to change the density estimator, which it works in many cases, but many people don't like. Decomposition-based algorithms are a very interesting idea that comes from operations research. In this case, the original multi-objective optimization problem is transformed into several single-objective optimization problems, but in this case, all the problems are solved simultaneously. The epsilon constraint method does this sequentially. This is very expensive, you do it sequentially. Additionally, decomposition-based methods don't require really additional information to do the decomposition. Epsilon constraint requires something we call the nadir point. So they offer several advantages because they use something called neighborhood search. Also, these algorithms scale properly with the number of objectives. That means they are able to solve problems with a higher number of objectives, although they need more weights because the weights define the search directions. However, the increase which happens with the number of objectives is only linear, is not exponential. So it's something we can afford in terms of computational cost. The main drawback of these algorithms, the composition-based algorithms, is that they rely on something we call a scalarizing function, and the scalarizing function is biased towards Pareto fronts that fit in a simplex. So if the Pareto front for some reason doesn't fit in a simplex, then scalarizing functions provide a very poor performance. This is not usual in practice, but it's possible to simulate the condition in which the Pareto front doesn't fit in a simplex. And then, of course, in those artificial problems, these algorithms don't work properly. The last group are indicator-based algorithms. In this case, the idea is that we use a performance indicator instead of Pareto optimality to select solutions. However, for this to be possible, the performance indicator must fulfill certain mathematical properties. It turns out that there is only one known performance indicator that fulfills this requirement. It's called the hypervolume. However, the hypervolume has the problem of being very computationally expensive. The cost of the hypervolume, or computing the hypervolume, increases polynomially on the number of points, but exponentially on the number of objectives. This is very bad, because if we reach even 5 or 6 objectives, the cost may be prohibitive for a traditional execution of the algorithm. People have been working around this for many years, trying to find ways to reduce the computational cost of the hypervolume, but this doesn't seem possible, except for a few cases and for low dimensionality. There are other performance indicators that are not as good as the hypervolume, but in practice they work. However, most people don't like. It's an interesting area. I particularly like this area a lot, but not that many people are interested in indicator-based selection. Regarding density estimators, as I mentioned before, this is a very important mechanism, and many proposals have been made, going from fitness sharing, clustering, entropy, the use of adaptive grids, crowding, performance indicators, and parallel coordinates. Actually, performance indicators are relatively popular as density estimators. They are not popular as selection mechanisms, but as performance indicators, many people have used them, particularly the hypervolume. Some of these density estimators are not scalable. For example, adaptive grids are intended only for 2 objectives. Others are scalable, like clustering or performance indicators or parallel coordinates. Okay, let's get to reproducibility. In this case, something I want to mention is that, as being a guy who was in this field since the 90s, I sort of witnessed a lot of the development of the field, because as I said, between 1985 and I will say 1993, almost nothing happened really in IMO. And I was a PhD student from 91 to 96. So at that time, I was able to read some of the early papers on IMO from Carlos Fonseca, from also Jeffrey Horn and a few other people, Kalya Moideb, while I was a student. And I witnessed this evolution on how reproducibility radically changed, same as validation in this field. So in the early days, and I can say the early days go from, of course, 1985, when the field was born, to the year 2000, more or less, perhaps 99, reproducibility was not a major concern. Nobody cared about this at all. When you had an idea for a new multi-objective evolutionary algorithm, the validation was very simple. You use a graphical comparison. You will plot Pareto front generated by algorithm A, then the Pareto front generated by algorithm B. And this was like an R appreciation class. You will say, look how this front has some holes, and the other one generated by my algorithm doesn't have the holes, and so on. But there were no performance measures, no metrics that could say numerically algorithm A is better than algorithm B. Also, there were no benchmarks, no actual test problems. Test problems were originally proposed in 99 by Kalya Moideb. He proposed the first benchmark. Then in 2002, in 2000, there was the first set of test problems that people actually used, because depth problems were not very popular, but the so-called SET-DT, the Sitzler-Depth-Thiele test set, some people still use today, was introduced in the year 2000. And then it's more popular, the DTL set test problems introduced in the year 2002 in a conference. And in 2005, a group from Australia called the Walking Fish Group introduces another set, more challenging, that was published in a conference, and the journal version was published the year after, in 2006. But at that time, people were already using some performance measures. The first performance measures were proposed in the mid-90s. For example, in the original paper of NSGA from 94, there is a proposal of a performance measure. Fonseca also has one in 93. But performance measures start to become common in the late 90s, is when people start to use them. And in the 2000s, everybody was using already performance measures and the first test problems. We normally assess convergence and uniform distribution of solutions. Those are the two main things. There is a third one, which is to generate several different solutions, not repeatedly the same solution. Now, in these early days, researchers were not, how to say, they were not eager to share their code. I really don't know the reasons, but this, when I give my talks about IMO, I always tell the audience, and they normally laugh about this, but it's true, that when I was a student and I started in IMO back in '94, I remember sending an email to Kalyan Moideb asking him for the code of NSGA. And he replied and he said, sure, I will send you the code. And I'm still waiting for it. He never sent it to me. He probably forgot. But the thing is, at that time, it was not popular. However, when the NSGA2 gets published, they decide to release the code. And many people believe that this was a key issue of why NSGA2 became so popular. Not only because they released the code, which of course helped a lot, but also because the code was very good. The algorithm was really very robust. It included a few test problems in the code. It had both binary encoding and real numbers encoding for the decision variables. And it was easy to use. In contrast, before that, in the 90s, a few algorithms had the code available, for example, MOGA from Fonseca, but you had to pay. And if you were a student, it was not too much, but as a student, it was against my religion to pay for software. And I had to do it my own. I had to implement the algorithm on my own. And it was not easy to implement these algorithms. So as a consequence, there were very few comparative studies of these early algorithms developed in the mid-90s, because you had to implement them and there was no certainty that your implementation would be correct. How could you know that? You rely on what was in the paper, and sometimes not everything was in the paper. They were using some obscure parameter, some strange mechanism, something that was not included in the paper, and there was no way of knowing that. So still, people trusted somehow these comparative studies conducted in the mid-90s, but as I said, they were not very popular. So not having the code, I believe, was a serious limitation at that time for the development of the field, clearly from the mid-90s to the early 2000s. When Eckhard Sitzler publishes SPA in '99 in the transactions, he decides to release the code of his algorithm. And soon after that, they propose PISA, is the reference you will see at the bottom of this slide in 2003. PISA is very interesting because this is the first platform in which they encourage people who develop algorithms to include the code of their algorithm under a common platform, rather than just releasing the code as Kalyan Moideb did with NSGA2. They say, why don't we follow the template from this platform so that all the algorithms have sort of a similar format, and it makes things easier for users. So they can sort of pull the algorithms they want from the platform rather than running the codes differently in different platforms. So I believe this was a very important step, although not many people liked PISA. Particularly, I didn't, we added code to PISA, but I didn't like the way in which you had to use PISA, but I liked the idea. The idea, I think, was very good. It's just the execution of the algorithms under the platform was a bit cumbersome. It was not trivial to use it. So there are several issues that apply particularly to IMO when we want to deal with reproducibility. For example, one of the issues, and this applies to software in general, of course, I'm a computer scientist, so I know this, but within evolutionary algorithms, I think it should be very clear that the implementation of a multi-objective evolutionary algorithm is significantly more complex than the implementation of a traditional single-objective evolutionary algorithm. Not only because the selection is different and we have to add non-dominant sorting and all this, but also because it's not only that we use the density estimator, we use other mechanisms. For example, elitism in multi-objective optimization is different. We normally use a data structure to store solutions, and some people add the density estimator to this data structure. So the implementation is not trivial. Of course, this is not thousands of lines of code, but it's a non-trivial implementation. And many of these algorithms rely on several non-intuitive parameters, which normally are not explained properly in the paper in which the algorithm is introduced. So not releasing the code makes it very difficult to reproduce the actual behavior of these algorithms. There is this story that is kind of famous today from Kalya Moedeb. Kalya Moedeb, when he publishes NSGA3 in 2014, he's forced in a way to not releasing the code because he sold some application that he developed for a Swedish company and made the mistake of including NSGA3 as part of this code that he gave to the company. So in other words, this Swedish company has the copyright of the code, the source code of this algorithm. So when he published the paper in the transactions, he had to remove the description of one particular mechanism, which actually makes a bit more difficult the implementation of NSGA3, which is not trivial. Even if you explain that mechanism, is not trivial. So as a consequence, the first public domain implementation of NSGA3, which was done by a guy in Taiwan, is somehow unreliable. We don't know if it's correct. Kalyan said it's not correct, but the funny thing is today you will find many papers on improved versions of the NSGA3. But how can you prove a code that is not available? So they are improving the version that somebody else developed, which may or may not be correct. And eventually they will find something that works very nicely, but it makes things much more difficult. So over the years, many more people have moved towards releasing their codes. Several journals are now encouraging this, as I mentioned in this slide. For example, the new ICN transactions on evolution and learning and optimization from Sigibo, the guys who organized Gecko, they encourage that you apply for a reproducibility label, and they have members of the editorial board who are in charge of this. The IEEE transactions on evolution and computation has a license of Ocean, so you can release your code and test it in Ocean. So it's up to you. It's not mandatory. Perhaps in a few years it will be. It's not right now. But many authors are encouraged to do this. And of course, having different platforms for the software makes the comparison a bit more tricky, but it's better than not having any code available at all. You know, if you tell me I have my code in Python and I develop my algorithm in C, you know, the comparison may not be fair if we introduce time, because Python is much slower than C. But having the code will allow me to develop, if I wish to, either a Python version of my own algorithm or a C version of the Python algorithm, right? So it makes things a lot easier for us. Reproducibility, just to conclude, is very important, not only in EMO, but I will say in evolutionary algorithms in general. At Gecko, there are people who have been sort of tracing for each paper that gets presented orally, which ones have this sort of reproducibility label. And the percentage is very low. It's very, very low. Very few people are still releasing their codes using platforms like GitHub and so on. Variations of existing multi-objective evolutionary algorithms have become a common practice because the source code was made available. That's the case, for example, of MoIAD. MoIAD originally, the code was released in C in the web page of Xinfu Zhang, which is the main author of this algorithm. Over the years, they moved this to GitHub because there are many versions now of MoIAD. But today we have entire platforms available. One of the most famous is PlatEmo, which is in MATLAB, and it contains over 100 multi-objective evolutionary algorithms. But there are others like JMetal that was developed in Spain and contains an important number of algorithms. There are versions in C, in C++, in Java, and I think also there is one in Python. So these platforms have become relatively popular today for validating new algorithms. It makes things a lot easier because you can plug in your own algorithm and then automatically select how many do you want to use for your comparison. So for example, if you're working on what we call many objective optimization, you just select the algorithms that were developed for many objective and you can conduct the validation very quickly. Reproducibility is becoming increasingly important in this field in IMO, and it may become mandatory in the next few years. We don't know. Some people are reluctant to do that, but it may happen. And I believe it's very important to improve the respectability of the discipline, because today there are, for example, many meta-heuristics that people have severely questioned, that they are not real in the sense of not being new, that they are sort of making up a metaphor, but the actual implementation is differential evolution or some other well-established meta-heuristic. So having the code of all these proposals will make clear that we are not proposing a fake algorithm, and we are not proposing, we are not reporting fake results on the performance of our algorithm. So this, I believe, is very important, not only because it makes easier for us, who, algorithm developers, to validate our new algorithms, but also because this is the right way to go in terms of methodologies from computer science, and also in terms of taking this field seriously, that we are making serious proposals and we are not making up anything. If you want to know more about IMO, you're welcome to visit the IMO repository, which is available online. It has a large database of bibliographic references, over 13,000, which include more than 300 PhD theses. My PhD thesis was number 5 in the field. Now there are hundreds of them, and a large number of journal papers and conference papers. We also have their links to these platforms I mentioned, to particular implementations of some algorithms in C, Java, Python, MATLAB, and so on. And that's all from my side. And if we have time, I will be happy to answer any questions. Thanks a lot.
Thank you very much, Professor. I think that was a fantastic talk summarizing the evolutionary computation, starting from the very early researchers who might not have been very much familiar with all these complex and the vast amount of work that you have done. And it was a very good summary. And thank you very much for the detailed account on the reproducibility as well. Because well, I think that one of the main challenges that the current young researchers are facing, as you correctly pointed out, are let's say, the small details that probably are very important, but however not being properly captured in the publications. And yeah, so thank you very much again for being with us. So now we do have time for a few questions. So I would like to invite the audience to start with the questions.
May I ask?
Yes, please.
Okay, thank you very much. It's indeed a very nice presentation, and I like your background and the red shirt as well. So my question is about, I want to know, because we know that, deep learning has emerged a lot, and there are lots of codes related to deep learning. And we also know that deep learning, along with various, evolutionary algorithms are incorporated in various algorithms and methods. Not that much, but what do you comment about that? Like, the connections between these two, multi-objective evolutionary algorithm as well as deep learning, and the progress and hope, and which field, which areas we can explore further. If you just give a little bit more on that. Thank you.
Sure, that's a very good question. I believe the main benefit of combining deep learning with multi-objective optimization could come at doing multi-objective classification, which is still not very common. Some people have done that in the past, but not using deep learning, using traditional neural networks and also fuzzy logic. because in some classification problems, there are really several issues that you want to deal with, not only a single objective of getting, for example, the best accuracy of the classifier. Sometimes you want to get, I don't know, minimize, if you are evolving rules, for example, compactness and other aspects. In deep learning, a few people have tried to optimize the parameters of the network, but this is difficult because evolutionary algorithms are not very good for such a large scalability, for this very large number of parameters that the deep learning involves. So I think it will be easier and more profitable if we move towards modeling the problems that deep learning is solving as a multi-objective problem, and try to use multi-objective optimization concepts to sort of match the classification criteria that are being used. In that area, I haven't seen much work yet, and I think it has a lot of potential. Most people have gone on the other direction of optimizing the parameters of the network, but in there, I think it's difficult because it's difficult to beat gradient methods.
Yeah, exactly. Thank you so much, because we can see that even one of my works we used just for parameter optimization or something like that, but not the other way, as you mentioned. Yeah, no, I understand the point now, and thank you very much.
You're welcome.
Thank you very much, Professor Atikur Rahman Ahad. And any further questions from the audience?
Yeah, I have a question.
Yes, please.
Professor, thank you for your nice presentations.
Thank you.
So my question is that there is a problem in the optimization about how you can ensure the balance between the exploitability and the explorations. So can you please suggest any method that will ensure the balance between the exploitability and the explorations? That is, it will become a hyper optimization algorithm.
Yeah, well, this is the holy grail in evolutionary algorithms, how to balance these two things, exploration and exploitation. In multi-objective optimization, some people have worked on that. Peter Bosman has a very interesting paper from 2003. But in general, there is no standard mechanism to do this balance because it's a pretty much problem-dependent thing. It's very difficult to come up with any sort of hybrid mechanism that provides the ideal balance for an arbitrary problem. You can probably do it for a particular domain in some cases, but it still has to be some sort of online detection mechanism, because when to switch from one to the other depends really on the state of the current population. So it's a very complicated problem. In multi-objective optimization, is even more complicated because we are converging to a set, not to a single solution. So how do you know that the set has the proper diversity, for example? It's not trivial to get to know. First, you don't know if you have converged, and then you don't know if the diversity that you have in the population is the one you are expecting. In single objective is a bit easier because once no improvement is achieved, you can assume you already converge to the best possible solution, not necessarily the optimal. But in multi-objective, it's possible to assess convergence of a set, but it's tricky because sometimes if you use a performance indicator, will tell you, yeah, this set has a better convergence than the previous set, but the difference is meaningless. Is 10 to the minus 10 or 10 to the minus 20. So it's basically the same set. So you're not improving this set anymore. You may be improving one or two solutions out of 100, but not the whole set. So doing the switch is tricky, but some people have tried to do that in multi-objective optimization. As I said, Bosman has one approach. There have been others over the years, in the last 20 years, but we don't have a standard mechanism for that.
Okay, thank you.
Thank you very much, Professor Shahraz Hussain. And yeah, so we have time for another last question. So anyone else? So if not, I would just request you, Professor, to give one message to the audience that is there, because well, this is also something which has been broadcasted in YouTube, and then we do have some more people there in YouTube also watching it. So for the younger generation, to encourage them to share their code, share their data set that they are working on to foster reproducibility. So please, well, if you say a few words again, encouraging them to do so.
Sure. I know one of the issues that has prevented, and this is more, I will say, for people from my generation, not for young people. Some people are sometimes reluctant to release their code, to share their code, thinking somebody else will steal their idea. And this is very understandable. But we now have this platform like GitHub, in which if you release the code, it's clear that it's your code. You can add your information in there. Also, I encourage young people who are interested in doing this to get updated versions in case they modify the code. All of this is very helpful. And you can link to this some document, for example, a technical report, even if it's not refereed, it's not a publication by itself. That way, if this is your concern, the credit will be there. And in my experience, whenever we release the code of an algorithm, it gets more citations and more people use it, as opposed to the case in which you don't release the code for whatever reason, you decide to rely only on the paper. So I think it's not only a good practice, as I said, it's something that at some point will become a trend, and it's the correct way to go, because as we said, if you don't really have anything to hide because your code works the way it should work, then it's perhaps not fancy, not elegant. Don't worry about that. We don't care about that. Our code also is not fancy. We are not, professional developers, but it works. For us, what is important is that it does what you are saying in the paper that it does. And we will make sure that when doing the comparison, we will do a fair comparison if we have your code. So it's important, as I say, not only as a practice, but also as a methodology within computer science, because only in that way, I think we can show that we're a legitimate research area, that what we are doing has really some meaning, some value, and we are not making up results, which is a bad practice, not only in computer science, in other areas. I think you are aware of these major scandals in other areas in which they falsify data to produce a paper. So to avoid that people believe, the results are too good for the algorithm to be true, so I think the guy is cheating, just release the code. If they try it, they cannot say anything. It's there, and this is not subject to any debate. Either works or it doesn't work. So I think you should go that way for young people. If you, as a young generation, sort of make of this a common practice, I think we will have a much more robust and solid field in the next 20, 30 years. That's what I think.
Yeah, thank you very much. I really appreciate it. I sincerely believe that your message will reach many people and would motivate many young researchers to start adopting this good practice, and this will eventually lead to a better scientific community, which would adopt reproducibility and sharing of information. So again, I would like to invite all the attendees who are present here to join me in thanking Professor Colo Colo here at this conference. And thank you very much from the bottom of our hearts, because, I know that you have been very busy, but still you manage this time to share your experience with us. Thank you again for here at the conference.
Thank you. Thank you for inviting me.
Bye-bye. So now, if we are going back to the session, because we had one paper which we cannot present due to technical issues. So it was paper number 19. So Professor Shanam Kasa, would you like to resume with the paper, please?
Yes, Professor.
Please.
So I would like to invite paper ID 90, I think, a hybrid deep learning system to detect face mask and monitor social distance. I would like to request, the author to present the paper. Nadia?
Yeah.
Good evening, everyone. Thank you for giving me one chance again. I'm Shirajum Nadia Haq from Bangladesh. As one of the author of this paper, I'm presenting our research work, paper ID 19, entitled to a hybrid deep learning system to detect face masks and monitor social distance. We have arranged our content as you can see in the screen. Coronavirus disease is an infectious respiration illness caused by severe acute respiratory syndrome, coronavirus 2, which performs human-to-human transmission. It was first discovered in Wuhan, China in December 2019, which globally corresponding to a pandemic. Disseminated by infected individual coughs or sneezes, saliva droplets or discharge from the nose. It mainly affects the lungs and in extreme cases, it can lead to RDS and pneumonia. The biggest difficulties is that no effective therapeutics have not yet been reported, so the World Health Organization recommended us to wear face masks and to be maintained social distancing by keeping a distance of at least 2 meters between two individuals. Thus, it can be stop spreading the virus and control the community transmission. The most common signs and symptoms of COVID-19 are fever, lightheadedness, headache, dyspnea, dry coughs, loss of taste and smell, and lastly, diarrhea and awareness have also been mentioned in few occasions. So the questions are how to develop an expert system for face mask detection and monitor social distancing. Is the performance of the proposed model better than other systems developed previously? In this research, our main goals are to develop a model to detect face masks using deep learning approaches, to measuring the distance between two people and monitor people if they maintaining social distancing and track their violation of the rules, and lastly, to distinguish the performance of the proposed models comparing with other CNN LSTM model utilizing in previous studies. Since this research focuses on building a hybrid deep learning system, two different system architectures are used. One, the dataset is pre-processed and the dataset is split into two parts, training image set, then it is trained the learning model. This learning model is then tested to classify whether the images are masked or unmasked. In this figure, it shows the system architecture for social distancing. To achieve this, the input video is trained by applying the ULOKitri model, which measures to calculate the distance between centroids of people standing side by side. We used here Euclidean distance to calculate the distance between two centroids. We collected our dataset from the open source Kaggle. Here we use a certain number of with masked images and without images. Without masked images. Dataset at first we load dataset and label them. Then we perform grayscale conversion to convert colorful images to black and white and minimize the complexity. Next, we use normalization process to rescaling the images into a size of 224 by 224. Afterward, data augmentation dataset. In our system architecture for face mask detection, we applied MobileNet V2 for the model, which performs depth-wise favorable convolution, and it is truthful replacement for standard convolutions. For monitoring social distancing, we used ULOV3 tiny system, which is the compact version of ULOV3 using fewer layer. ultimately reduces the inference time. After implementing our training module in Google Colab, we got our results. These two figures show the training and validation accuracy and training and validation loss respectively. Here, the blue curve indicates the validation accuracy and validation loss, and the red curve indicates the training accuracy and training loss. Our proposed model achieved an accuracy of 99%. The figure shows the classification report of our proposed model, which get 99% value of precision, recall, and F1 score. The figure shows the real-time detection by showing with mask and without mask boundaries. The aforementioned model simultaneously detects multiple individuals in real time using MobileNet V2. For social monitoring system, the YOLO V3 models are used to detect social distance between objects. As you can see in the figure, it shows the violation of social distancing. Our proposed model is compared to existing work. The proposed model MobileNet V2 outperforms the model used in other research works. Our proposed model gets the 99% of accuracy. Here you could see in the table that CNN has the lowest performance any of the models. In monitoring social distancing system, comparing with YOLO V3 model, our proposed model outperforms with a difference of 9%. Our model can be further embedded with Android application which utilizing mobile cameras. So at the conclusion, we can say that this research focuses on providing a cost-efficient and computationally deep learning-based system which will not only detect face masks but also monitor social distancing between people. Here, two systems are developed. The face mask dataset is trained by using MobileNet V2, resulting in an accuracy of 99%. Further, YOLO V3 Tiny is used to monitor the social distancing among individuals from real-time video footage. Lastly, in terms of speed and accuracy, YOLO V3 Tiny exhibited better performance. And this brings us to the end of this presentation. I would like to thank you for your time and attention today. Thank you.
Thank you so much. Dear audience, if you have any suggestion, query, please feel free to ask. I have one concern. May I ask? Shirajum. Shirajum.
Yes, please.
I mean, you are planning to determine the social distance, right?
Yes.
For measuring the social distance, the perspective is an important issue, right? So this is at the same time a challenge for us also. So how do you, I mean, overcome this issue? Perspective.
Yes, this is very challenging for us to control the distance. But yet we have to done with this model. As you can see the in the real-time video footage picture that it shows the violations of social distancing. So it might be helpful for to detect between the social distance. I think so.
Okay, if there is no camera, in that case, we cannot measure the social distance, right?
Actually, we propose this model for using camera. We will hope to use this model when we can use this in different section, like some offices, garments, where a lot of people are entering every day. So if we use a video camera footage, it automatically detects. So it can be helpful, I think.
Thank you, Sojan.
Thank you.
Mufti, over to you.
Okay, thank you very much, Mr. Kaisar, for chairing the session. So with this, actually, we are at the end of the hybrid sessions that we had here. So we had one hybrid session focusing on the people who actually did have difficulty in obtaining visa to arrive to the country. So thanks to the organizers who actually did make this arrangement to have this session in a hybrid mode. And then, of course, I would like to thank all these attendees who have been here, who have contributed and presented the papers here. So I would like to invite you all to join the other hybrid sessions that we have. So including the one of tomorrow, which is going to start at 4:30 tomorrow Italian time. So which is again GMT +4. Okay, so please do attend that particular session. I'm really sorry that not all the sessions are hybrid. So most of the sessions are in person. So you unfortunately will not be able to attend all the sessions in this particular case, but well, I do request you to attend the session which is starting at 4:30 tomorrow Italian time. And then there will also be the third day. During the third day, there will be sessions starting from 9 to 9:45, which is on Saturday. And then 11:20 to 12:35, then it's going to be another hybrid session. So hoping to have you all during all these hybrid sessions. I'm going to draw the curtain for the day. And thank you all again for attending the session. And I wish you a very pleasant evening. And thank you again. Take care. Bye-bye.
Thank you.
Thank you.